Hello and welcome students to another episode of our Programming Fundamental course with C#. This is part of a larger video series of a course that I do at the HTL Leoning. If you are not in my course at the HTL and you follow just online, please make sure that you watch the previous videos. I will add a link to the playlist in the description of this video. Today, our main topic is the for loop. Are you ready for some additional loop adventures? Let's dive right into the most versatile, but also a little complicated loop. But don't worry, we will definitely understand it. We will definitely work our way through. Let's jump into the slides here, and I would like to introduce you to the for loop. This is how a for loop looks like, and if we split it up, we will see that the for loop consists of three different things: the initialization part, the condition part, and the increment-decrement part. Sounds complicated? Sounds a little bit theoretical? Well, let's jump right into the code and explore the possibilities of the for loop. Here we are. Let's implement a very simple program. We will count from 0 to 9, and we will print the numbers between 0 and 9, including on the screen. Before we try to do that with the for loop, let's implement that with a while loop. So we start with the value 0, then we run the while loop as usual. We have practiced that quite a while. We will print I on the screen, and we will increment I. Now this is exactly what we can do, and if I run the debugger just pressing F5, it will print the numbers 0 to 9 on the screen. Works perfectly fine. We have 10 numbers, exactly what we wanted. Now let's try to rewrite that with a for loop. And for that, I would like to point out the different parts of the loop that we already have inside of this while construct. We will use all these parts in our for loop in a second. This here, marked in red, is the initialization part. It happens once before the loop is executed. Now the next one, this one, is the condition part, here marked in green. It is evaluated before each iteration of the loop. And last but not least, we have the increment part, here marked in yellow. It happens after the code block of the loop has been executed. So these three things, red, green, and yellow, will be also part of our for loop. That's essentially what a for loop is all about. The for loop is about writing such counting loops in a shorter way. You can express every for loop in a while loop too, but with for, it simply is shorter. That's the point here. So let's try to rephrase that into a for loop. Let's separate the two parts here and write a for loop. It starts with the for, and the first thing that we do is we copy the initialization part down to the for loop. Next, we copy here the condition into the for loop, see? And last but not least, we copy, without the semicolon at the end, the incrementation part in this part. Now the problem is that we have I here and I here because I have written both things here in one and the same program. So let me quickly take that one and comment it out so we don't have a naming clash. We cannot reuse the name I here, but we still have our previous code up here to compare the while loop with the for loop. Inside of the for loop, we simply have to do a console write line I, as you can see it here, and that's all. And now compare, zoom in a little bit, and now compare the old version with the new version. Do you see how much shorter that is? And the reason why it is shorter is because we have here everything put in a single line. Here you have the initialization part. Here you have the condition part. And here you have the increment part. So it's just a different way of expressing a thing that you have already learned. And from now on, whenever you have to count in some way, or whenever you have to count in some way, you can prefer the for loop over the while and the do while loop. Does that mean that you never use the while or do while loop? Absolutely not. There are different kinds of scenarios where you do not count in any way. And then Then you use the while loop or the do while loop. And that's the kind of difficult thing in programming. You have many options, and depending on your use case, you have to select the right construct. How do you do that? Practicing. Gather experience by practicing, and then you will get an intuition when to use which loop, and which loop fits perfectly to your concrete scenario. Nice, let's go back to the slides and quickly repeat what we did. The for loop, as you can see here, execution order. First, we do the initialization part. It's done before the condition. Then we do the condition evaluation. It's executed after the initialization and before. That's the important one, not after. It's not a do while, it's a while loop before the execution of the code block. Then we execute the code block, and finally we do the increment. And then we jump back, then we jump back to the condition again. So let's evaluate that, how this works in, for instance, a for loop like that. I have it here in the slides, but I would like to show you that live by using the debugger. I will change that to 3 so we don't have to step through it so often, and I will set a breakpoint here and run this thing in the debugger by pressing F5. C# will stop here. You see, first we are here at the initialization part, and if I press this button here, we initialized I with 0. Next, we go into the condition part. We check whether I is lower than 3. 0 is lower than 3. That is true. So we go into the loop. We execute the console statement and watch where we are heading now. Next step, and we are in the increment part. You see, now I is incremented. I has been changed from 0 to 1. We do the condition evaluation again and print everything on the screen. And increment, check, print. Increment, check, print. Finally, increment here. And now, as you can see here, we are on 4. 4 is no longer lower equals 3. So, whoop, we jump out of the loop and our program is done. So we have printed 0 to 3. This is how it works. So the loop in our program starts here, goes to the condition part, then executes the block, goes back to the incrementation part and into the condition again. And this thing here, let's mark it in a different way. This is the loop. You see, this is the loop that we are doing. The initialization is only executed once, but then we are looping from condition, block, increment, condition, block, increment, condition, block, increment. This is what we are doing here. Okay, very nice. I summarized that here on the slide. I don't need to repeat that because I already told you. So, time to exercise, right? So you have now the possibility to try that. First, I ask you to write a relatively easy program. Essentially, you are doing exactly what I showed you just now, but you should do it on your own. Write a program that prints all numbers between 1 and 10 on the screen. And as an advanced version, print the numbers between 1 and 10, but calculate the value times 2. Try to implement both solutions. And the important thing is, just like I did it before, pause the video here and write the level 1 exercises first with a while loop, and then you jump to the for loop. I will not show you the solution here because you have already seen the solution just in my example before. If you are not sure, use the slides or go back in the video to see how the for loop works and try to solve this level 1. Once you're done, come back to this video. Welcome back. I hope you solved level 1. Now let's take a look at level 2. Level 2 is a little bit harder. We have to print all numbers between 1 and 20 that can be divided by 3 without a remainder. First, we want to print the numbers, and then we just want to calculate the sum of all these numbers. So let's try to tackle level 2. Pause the video and try it on your own. Once you are back, I will show you an example solution. Okay, you are back. So let's try that together. Let's try that together, and you can compare your solution with my solution, okay? So level 2, we need to print here. We can use the program that I already wrote here, so let's just clean it up a little bit. So let's think again. We need all the numbers between 1 and there's a mistake in my slide here. Here says 1 and here it says 0. That's an inconsistency. You can choose on your own. I will start with 0, and I want to print all the numbers between 0 and 20, including 20, that can be divided by 3 without a remainder. So we start with 0 and here we say 20. That is correct. And now we want to print here all the numbers that can be divided without a remainder. The first solution that we could do is we could say if I modulo 3, can you remember? Modulo operator gives you the remainder of the division, equals 3. In this case, we want to print I. See? So here we have a loop with an if statement embedded. Let's see, let's run this thing and let's see what we will get. We will see, I have the breakpoint still here. I don't need the breakpoint. We just want the results 0, 3, 6, 9, 12, 15, 18. And if you check that with my slides, that looks okay. So we have one possible solution. But if we think very closely about what this problem here states, we will see that we really don't need the modulo operator, because which numbers can be divided by 3 without a remainder? It's always a multiple of 3, right? So we start with 0, we add 3, we add 3, we add 3, we add 3. So we can simplify our algorithm by using a small mathematical trick. And this is what I want to show you here. We can get rid of this if here, and the important thing that we now will do, and that relates to the for loop, is that we can say plus equals 3. We do not need to increment by a single number in the for loop here. We can increment by higher numbers. Or of course decrement if you want to count down. That's just up to you, okay? So I plus equals 3 means we jump from 0 to 3 to 6 to 9 and so on. And if we run this program, we hopefully still get the same result. See? Works perfectly fine. Good. Now the next exercise here, just calculating the sum, is also not very difficult if we write it with a helper variable. So let's do the following. Let's write a helper variable here. Let's say int sum equals 0, and then we simply add I to the sum. Sum plus equals I. That will add one number after the other to sum. The console write line is no longer needed inside of the loop, so we can move it outside of the loop and just print the sum here. So we do exactly what we did before, but we do not print every single number on the screen, but we just printed the sum on the screen. So let's run this thing again, and let's see what comes out. The result is 63. Let's check that with our slides. Yes, it's 63. Very nice, level 2 done. So let's get to level 3. That is a more complicated one. Here, we want to generate the Fibonacci sequence. The Fibonacci sequence is a famous list of numbers. It starts with 0 and 1. Every Fibonacci sequence, the Fibonacci sequence, always starts with 0 and 1. And then every further element is calculated by adding the two numbers before in front of it. So the next element is 0 plus 1, and that is 1. The next element is 1 plus 1, that is 2. The next element is 1 plus 2, and that is 3. The next element is 2 plus 3, and that is 5. The next element is 3 plus 5, and that is 8. You see? So we are shifting this window kind of to the right. So here we take these two numbers to calculate the next one, which is 2. Then we take these two numbers and we calculate the next number, and that is 3. And then we take these two numbers. By now, I think you got the point. 2 and 3, which calculates 5, and so on, and so on, and so on. So we are shifting everything to the right. Please pause the video and try to come up with a solution for the Fibonacci sequence. You do not need to immediately write it with a for loop. Try it with a while loop and think about whether you can express that in a for loop too. I will show you a sample solution in a second. For now, pause the video and play a little bit with this level 3. It's not that simple. Can you make it? Try it. Welcome back. So let's take a look at this example here, the Fibonacci sequence. Let's go here. Let me clean it up here a little bit. Let's think about the Fibonacci sequence here. We will start with 0 and 1. I told you that. So what we can do is we can simply print console right line 0. Sorry, let's do it that way. 0 and 1 on the screen, because that is fixed. Fibonacci sequences always start with 0 and 1. Now, of course, to calculate the Fibonacci sequence, we always need two variables, the first number and the second number. And this first and second number will then shift to the right step by step. So let's define here a helper variable which says first, we will start with 0 because that is the first number at the beginning, and second, which will be 1 because this is how we define the Fibonacci sequence. Let's first try it with a while loop. While, here we have it, and how long should we execute the loop? Until the second number here has reached 34. So we say while second lower than equal 34. Now inside of the loop we have to calculate the third number. The third one is this one. Let's call it the next number. So this is the first, this is the second, this is the next. In the next iteration, this will be the first, this will be the second, and this will be the next, as you can see here. So let's calculate the next one. So we say int next equals to first plus second. This is how we defined the mathematic to calculate the next value. Now we can print next on the screen. Console right line next. Okay, finally we have to shift first and second one step further. So we say first will be the second one. Before 0 was the first and 1 was the second. When we want to do the next calculation, 1 will be the first and the next one will be the second. So we can say first equals second and second equals next. With that, we have shifted everything a little bit to the right, and we can iterate and iterate and iterate. Let's see if that works. Let's run it again and let's see if it works. And we have 0. This 2 means that 1 has been printed 2 times on the screen. So we have 0, 1, 1, 2, 3, 5, 8, and so on, 255. Okay, we have I did a small mistake here. I have to say lower. I'm very sorry about that, because we do not need to calculate the next value once we have reached 34. We want to stop when we have reached 34. Let's run it again, and that will be fine. As you can see it here, very well. Now this is the while statement. Can we express that using a for loop? Let me show you an amazing trick regarding that. We can go to the while loop here and replace while with for. Now this obviously doesn't work because we need 3 parts, right? We need the initialization part, we need the condition part, and we need the increment part. But we can apply a trick here. We can simply say semicolon at the beginning and semicolon at the end, and by that we tell C#, hey, we don't have an initialization part, we don't have an increment part, we just have a condition part. So with that, we magically have turned a while loop into a for loop with minimal changes. Does it make sense? No, obviously not. We have to do additional changes. But I really like this trick because it shows you what the for loop is really all about. But let's take a look at the initialization part first. Do we have an initialization part? Well, kind of, right? We have an initialization part because we have these 2 variables, but these are 2 variables. How can we initialize 2 variables? Can we do that? Yes, we can. In the for loop, we can say int first equals 0, second equals 1, and with that, we don't need these 2 lines anymore. So yes, it is possible inside of the for loop to have multiple variables used for counting. That is definitely possible. You use the comma here instead of the semicolon to separate the variables that you would like to declare. That already looks kind of intriguing because we got rid of 2 lines. Let's delete them here, and let's think about the incrementation part. Do we have a kind of incrementation? Well, we have a very special incrementation here. We don't say plus plus or plus equals, but we shift our first and next values. See? We shift our first and next values. Can we also do that inside of the for loop? Of course, we can do that. Guess how? Yes, by using the comma statement again. So what we can do is we can take the first shift here and just move it up here. That is a simple one. The next one will be a little bit more tricky. We have to move that one, this one, also up to the incrementation part. And then we can get rid of this thing. We have one final problem. The next variable is currently a local variable inside of this block. So it's not possible to reference it outside of the block here in the for loop. So what we need to do is we need to declare the variable outside of the code block in next. And then we are fine. So you see, you have the initialization part here, you have the condition part here, and you have the increment part here in the third part of this for loop. If we run that, we hopefully get the Fibonacci sequence up to 34, and here you are, it works perfectly fine. So what you have learned from this exercise is that you can declare multiple variables in a for loop, and you can do multiple assignments or increments in a for loop. And it wasn't that complicated to turn the while loop into the for loop. Now, if you ask me which solution is better, I can't really say if the while loop or the for loop is the better solution. Both are perfectly fine. You can do both. It's up to you, as I said before, to come up with a solution that is easy to understand, easy to write, and easy to read for those people who would like to maintain your code in the future. That is your job as a programmer, to write the program that is efficient, easy to write, and easy to read, understand, and maintain. That is what I wanted to show you in the for loop. The rest of the slide deck here for the for loop consists of additional exercises. Take a look at these exercises. You will draw some smileys on the screen. You will learn about nested loops, as you can see here. You will draw smileys and pizza pieces here on the screen. I have a little number guessing game here that you can implement. And at the end, I have a speed coding challenge, which turns the thing upside down, because this will be the first time where you get a larger code piece, you have to write it, and then you don't have to come up with the algorithm yourself, but you have to try to read the code and understand what's going on. You will learn a bunch of new things in the speed coding challenge. In our exercise at the HTL, we will work through all these examples. If you follow online, please do these examples on your own. Thank you very much for following this video. I hope it was interesting. You mastered the for loop, and now we have a great foundation for the next video, which will come up probably next week, where we learn about methods. Don't forget, mastery comes from practice. Keep on practicing, keep on exercising, enjoy the rest of the day. That's all I have for you today. Goodbye. See you next time.